This is Year 10 Mathematics, the Introduction to Algebra. There's this classic meme about why algebra, and it just goes, another day has passed and yet again I haven't used algebra even once. And it's funny for me because I just think it's so wrong. When you're legging it out of period 4 and you're trying to work out, do I need to run down to the soccer oval to get that soccer goal before the Year 7 sniper, you're using algebra. When you're trying to work out how many dim sims you can buy at lunchtime but still have enough money to buy that girl you like a drink after school, you're using algebra. Algebra is about connections. It's about connecting the things we know or we understand to the things we don't yet know or the things we want to understand. Anytime we're using something we know to determine or plan or value or know or to do something else, then that's algebra at its absolute finest. Algebra is about reduction and restoration. When we deal with numbers in algebra, it's about looking at the properties of those numbers and the patterns and the occurrences that arise, and then making generalizations so that we can use those patterns to do something useful for us later on. In written form, algebra has three main components, the building blocks of algebra. We have terms like 3a or 1. These are individual things. These form the fundamental building block. When we chuck operations in the middle, then we get our expressions. And our expressions are typically made up with an addition or a subtraction between two or more terms. When we equate two or more terms or expressions using an equal sign, then we start to get equations, and now things start to mean something. Now we're starting to make connections. So what is it that we can use? What are the tools that we have to make these connections and to construct these meaningful things? Well, we have our order operations, we have our index laws, and we can abuse like terms. In 1999, NASA lost $125 million because people who were creating the software for a Mars rover used different units of measurement. It's so important for us that we use the same things to mean the same thing that we want it to mean, because otherwise people get lost in what we're talking about. And no, it's not always going to cost us $125 million. But when we say something, we want people to think the same thing we want them to think. We use PEMDAS or BODMAS or whatever it is that you've used before, the same order of operations, because it allows us to do things correctly and consistently. And part of that involves multiplying and dividing. In algebra, when we multiply and divide algebraic terms, we do so in a very specific way. First, we deal with the coefficients. We have 3a times 2b. The coefficients here are 3 and 2, so we can multiply them first. 3 and 2 is 6. The pronumerals are those letters, A and B. A times B is AB. And now, lastly, we can combine. 3a times 2b, we multiply the coefficients, gives us 6. We multiply the pronumerals, gives us AB. We combine it all together, and we get 6ab. The same thing happens when we try to divide. We deal with the coefficients first, and then the pronumerals. We divide the coefficients. We divide the pronumerals, usually using a fraction or cancelling numerators and denominators out with common factors, and then we combine right at the end. We can also do this using index laws. These are all the same index laws you've always learnt and you've been doing for a long period of time. We keep in mind that we need the same base to be happening. If we have a to the power of 2 times b to the power of 2, we don't use the first index law here, the base is different. But a to the power of 2 times a to the power of 5 is perfectly fine. We have the same base. Adding and subtracting in algebra looks slightly differently to what we've been doing normally. First, we have to check if we have this thing called the like terms, because once again, we want to be talking about the same thing. Looking at the first example, we have 3a, 2b, 4c, and negative 5d. Like terms require that we have exactly the same pronumeral raised to the same power. These are 4 different pronumerals, so they are not like terms. Down below it, you have 3a, a, negative 10a, and 6a. The coefficients are different, but our pronumerals are exactly the same. These are like terms, and we can add and subtract these as we wish. Heading up to the other side, 3a, 2ab, negative 4a squared, and 5 over a are not like terms, because these are different. We have 3a first, then we have 2ab, and ab is not the same as a, even though a features. Just like a squared is not the same as a. It is different, it's raised to a different power. and 5 over a is the same as 5 times a to the power of -1. We have a different power. They are not like terms. In the fourth example, we have 3a, 4b, -5a, and 10b. Here, the 3a and the -5a are like terms, the same pronumeral, raised to the same power, and the 4b and the 10b are like terms as well. So when we try and put this together, we have 3a plus 2a, they are like terms. So we just add the coefficients. 3 plus 2 is 5, a plus a, we keep the pronumerals the same, 3a plus 2a equals 5a. When we subtract, it's the same process, 3a minus 2a, they are like terms, 3 minus 2 is 1, we have 1a, which we can write as a. Moving on, we have 2a plus 4b minus 5a plus 10b. Again, 2a, -5a are like terms, we can subtract. So we wind up with 3a. We have 4b and 10b also like terms, but they sum to 14b. So that entire expression on the left-hand side is equal to -3a plus 14b. In the last example, the same sort of thing, we're looking for the like terms because we can collect them. A and 2b gives us 3a. -b and -3b gives us -4b, and -c plus 2c gives us c. To recap what we've covered today, algebra is about connecting things we know to the things we don't. It's about making the connections, and the building blocks that we use to make these connections are our terms, expressions, and our equations. In multiplying and dividing, we deal with the coefficients first, then we deal with the pronumerals. And when we add and subtract, we only look for the like terms because they're the only things that we can actually add or subtract. And so we deal with the coefficients and the pronumeral remains the same. Thanks for watching today. I hope that's been useful for you. We'll see you in the next video. This has been the introduction to algebra.